Okay, so let's finish 4.1 and 4.2, and then we'll go ahead and start 4.3 in this video. So it's more word problems, some business applications. The amount of money in billions of dollars lent to customers with credit scores below 620 for subprime mortgages can be approximated by the function g of x equals 200 e to the negative 0.2x, where x equals 1 corresponds to the year 2001. Find the value of subprime mortgage lending in 2016. So yeah, if x equals 1 corresponds to the year 2001, that means 2016 is going to be x equals 16. So g of 16 equals 200 times e to the negative 0.2 times 16. 0.2 times 16 is negative 3.2, so this is 200 e to the negative 3.2 power. And again, this is where we put it in the calculator to find an answer, or Google. And Google will know what E is. 200 times e to the negative 3.2 is equal to approximately 8.15. And it's in billions of dollars, so the value of subprime mortgage lending was $8.15 billion in 2016. If the trend continues, what is the first full year in which subprime lending falls below 33 billion? Try values in your calculator to see. Okay, so we're trying to figure out when is 200 e to the negative 0.2x less than 33. So let's try x equals 5. So at x equals 5, it's 73.6. So let's try x being 7. So x equals 7 is 49.3. X equals 10. So x equals 10 is 27.1. We got to make sure there's not one that's before that. So let's try 9 and go back from there. Oh, x equals 9 is 33.06, which is not less than 33. So x equals 10 is the first one. So what does x equals 10 represent? It represents the year 2010. And I'll let you go ahead and do 6, and we can move on to chapter 4, section 3, log functions. So the idea here of plugging in numbers is rather annoying. It would be nice if we can solve an equation for the exponent, and we will find a way to do that using logarithms. So logarithm is basically the inverse of an exponential, but it's also an equivalent form, so saying the same thing. So for all real numbers y and all positive numbers a and x, where a is not equal to 1, y equals log base a of x is in the equivalent form of x equals a to the y. Log form is short for what's called logarithmic form, and it isolates the exponent. So these two things, y equals log base a of x and x equals a to the y, are interchangeable forms. So at first, all we're going to do is practice writing between the two forms. So rewrite the following exponentials in logarithmic form. 2 cubed equals x, or 8. So that's a to the x equals y, or a to the y equals x. The exponent is always what gets isolated when we're converting it to log form. So we should get x equals the base of our exponential is the base of our logarithm, so log base a of y. So these are the two things that are the same. So in terms of 2 cubed equals 8, we get 3 equals log base 2 of 8. And all we're doing is rewriting for now. X to the 1/2 equals 9. We get 1/2 equals log base x of 9. Now you can also write it as log base x of 9 equals 1/2. These two are also the same. The order doesn't matter as long as you get everything in the right place. I know this 9 looks like an A, so let's make sure it's clearly a 9. 5 to the x equals 1/25. Rewrite it. Log base 5 of 1/25 equals x. So as you can see with number 3, this can sometimes help us get a variable by itself on one side. So we really just need to know how to evaluate logs. And we'll work on that in a second. But if we can go from exponential to log form, we should be able to go from log to exponential form. Log base 3 of 81 equals 4. Remember, the thing that's by itself becomes the exponent. 3 to the 4th equals 81. Log base x of 32 equals 5. X to the 5th equals 32. Log base 1/2 of x equals -4. 1/2 to the -4th equals x. So whatever's inside the logarithm ends up by itself in this way. So how do we solve logarithmic equations? We convert them to exponential form and simply solve them like we would have last chapter. So log base 8 of x equals 3. If we rewrite this, this is 8 cubed equals x. We know how to solve this. All we do is cube 8. So 8 cubed is 512 equals x, and we're just done. Log base x of 8/27 equals -3. X to the -3rd equals 8/27. Okay, so let's see, how are we going to do this? This is 1 over x cubed equals 8/27. We can cross multiply, so 27 equals 8x cubed, divided by 8. 27/8 equals x cubed. To get x, we take the cube root. So x is 3/2. To take a cube root of a fraction, you take the cube root of the numerator and the denominator. Lastly, 49, the log base 49 of the cube root of 7 equals x. This is 49 to the x power equals the cube root of 7. 49 is really 7 squared. The cube root of x, or of 7, can be written as 7 to the 1/3 power. So therefore, I will get 2x equals 1/3. Divide by 2. X is 1/6. Okay, so we talked about what an exponential function looks like in the last section. Logarithms are inverses, so let's remember what an inverse does. It takes the x and y values and it switches them. So if you recall from 2 to the x, 2 to the 0 equals 1, 2 to the first is 2, 2 squared is 4, 2 cubed is 8, and we also said 2 to the negative first power was 1/2, negative second was 1/4, negative 3 was 1/8. And we graphed it. Something like this. Going up on the right side and flattening out on the left. So if an inverse switches the xy values, we may not know what logarithm looks like, but if log base 2 of x is the inverse of 2 to the x, all I have to do is switch the x and y values that I see over there and see what happens. Instead of 0, 1, I have 1, 0. Plot that. Instead of 1, 2, I have 2, 1. Instead of 2, 4, 4, 2. Instead of 3, 8, 8, 3. That gives us this side. So instead of curving out and away up, it's curving away and out to the right side. Instead of -1, 1/2, we have 1/2, -1. 1/4, -2. 1/8, -3. So it looks like it's leveling off, going down instead of to the left. So this is what the logarithm looks like relative to the original graph 2 to the x. And we will do more logarithm properties in the next video.